Welcome to my channel. So let's have a look at problem 2323. Find minimum time to finish all jobs 2. So for this problem, we're going to share a greedy solution here. So actually for this problem, on first thing, we might think it's complex. So actually, if you analyze a little bit, it's actually a rather straightforward problem. So first I'll read through the statement of the problem, and then we will share the thought, and then write the short code. First, let's look at the statement of the problem. So we are given two zero-indexed integer arrays called jobs and workers of equal length. So where jobs I is the amount of time needed to complete the S job, and workers J is the amount of time the J's worker can work each day. So each job could be assigned to exactly one worker, such that each worker completes exactly one job. So we want to return the minimum number of days needed to complete all the jobs after assignment. Right, so this is the main statement. So let's look at one example. So in example 1, here is the jobs 5, 2, 4, and workers 1, 7, 5. So here is the output is 2. So we need 2 days to finish the job at its minimum. So if we consider assign worker 1 to this job, so it needs 2 divided by 1, that is 2, need 2 days. And then we assign the work 5 corresponding to this 4. We're going to need 1 day, right? So 4 divided by 5 is 0, but it needs 1 day, right? So we assign this worker 7 to job 5, so we need also 1 day. So here the problem the point of the problem lies in that we need to return the maximum time that taken for each worker to finish his or her job. So that's one point. Another point is that each job should be assigned to exactly one worker. So that's another point that the 2 points together make the problem very straightforward, I would say. Here's the constraint about the length. So that is the jobs and workers have length bounded above by 10 to the power 5. So with that said, let's look at the method here. The method actually we're going to share is a greedy method. So basically what we want to say is that we sort the jobs and workers, and then do the assignment according to the indices, do the assignment. In other words, we assign the smallest worker time to the smallest job. So that's basically the same. First, we'll write the code, and then we'll explain why this assignment would give us the minimum time needed to finish the job. So first, let's sort the jobs and workers from low to high. So I'll do it in place. Jobs sort and workers sort. And then in order to get the final result, I want to first initialize a result variable. We want to return its final state after the linear traversal of the 2 lists. So then I'm going to do the traversal. So for job time and for work time, I would use zip function, zip these 2 together, so workers. And then for this worker to finish the current job, the time needed, I want to first track this information. In other words, for the current worker, how many days does it take for him or her to finish the job. So I want to do a division. So use the job time divided by the work time. So if this the remainder is 0, it needs Q days sharp to finish the job. If R is not 0, it means we need Q plus 1 days. So we just make a check. If R does not equal 0, we're going to increment this Q by 1. So the state for the Q will be the days needed for the current worker to finish the job assigned. So what we want to return actually is the maximum of the result with respect to all the Qs. So we want to reset the state of the result and Q. And then after this loop, we're going to return the result. So that's all about this problem. First, let's do the case check, and then we analyze why this strategy will do the job. So yeah, it passes the case. So here I want to explain why this assignment will do the job. The point is that the finish time actually is the maximum days among all the workers that can finish the job. For example, worker 1 needs 3 days and worker 2 needs 5 days. Then the finish time will be 5. So in this case, assume if we do not do this kind of assignment, and then we fix a job that needs more time, then if we assign it to a smaller worker time, then it will increase the days for him or her to finish the job. So the overall result is that it makes the finish time larger. So that's the idea behind. Therefore, to summarize, we do the sort for jobs and workers, and then after sort, we just match each pair and do the assignment accordingly. Then what we want to return actually is the maximum time taken for a worker to finish his or her job in this assignment. So that's exactly what the code says, and especially for the linear scan of the two list sets. With that said, I guess that's about it for this seemingly complex but straightforward problem. Thank you so much.